Okay, last week we learned about the last week we learned about trig identities, which you should be familiar with. Last week we covered special angles and the values of the six trig functions applied to it. So last week we learned about this the 30, 60, 90 triangle and 45, 45, 90 triangle. And we were able to calculate the values of the sine of 30. We were able to calculate sine of 30, cosine of 30, tangent 30, and this is also going to be 60, 60, 60. And we learned that we learned that one of the values is a half, so root 3 over 2, and root 3, 1 over root 3. And for what is this? For this triangle, we learned that cosine is equal to sine, as sine of 45 and cosine of 45 are both equal to root 2 over 2. And that these are all the results we established last week. Okay. Oh shoot. Okay, please ignore that. Okay, good. So this week we're going to be looking at trigonometric identities. So trigonometric identities. And basically it relates trig functions with other trig functions. So to start off, we're going to get another triangle. Okay, never mind. We're going to get a triangle with sides A, B, and C. And by the Pythagorean theorem, we know that a squared plus b squared equals c squared. And now we're going to take the c term and divide the equation. We're going to divide both sides by c squared. And we will find that a squared over c squared plus b squared over c squared equals 1. And you know that from exponent laws, when both the numerator and denominator are raised by the same power, it's the same as a over c squared plus b over c squared equals 1. Okay, now if we recall our trig functions, sine theta, we're going to let theta be this angle, cosine of theta, tangent theta. We know that sine of theta is opposite over adjacent, so b over c, and this is a over c and b over c, and this is b over a. Okay, so now notice that a over c also appears here, so we can actually substitute cosine into this, sine and cosine into this. And the way you write squares is you put it over here instead of the brackets. And we'll name it theta plus cosine squared theta equals 1. And we have our first trig identity. This is actually called the Pythagorean identity. Okay, now from here we can derive other identities. So let's move our screen. And we're going to divide both sides by sine squared. So that's going to give, okay, so we're going to divide both sides by sine squared. Actually, another way of looking at it, right? Another way of looking at this formula, we can also use a unit circle, where it's the circle that has the radius 1. Center at the origin. Let's draw a better one than that. Okay, ignore the bad drawing, but the radius of this circle r equals 1. And we know that the equation of a circle is equal to x squared. So take this point, that's x, that is y. We take y squared, we take x squared plus y squared equal 1. And that's actually the Pythagorean theorem, right? But it's also the equation of a circle. And we know that the radius is 1. And if we take the angle of this line right here, and we essentially we rotate it to angle theta, sine of theta, sine of x, sine of theta is x over 1. Therefore, x is equal to sine theta. And cosine theta equals y over 1. Right? Because it's right, no, we messed it up. This is y actually. And this is x. Cosine is x. So therefore y is equal to cosine theta. And we can just substitute this into this formula and we get that. Cosine is x plus sine squared theta equals 1, and that we get the same result. Alright, now we can move on to the other trig identities. So let's move this. Okay, we don't need to move it. Okay, so we'll take this and divide both sides by sine squared. So sine squared divided by sine squared plus cosine squared divided by sine squared equals 1 divided by sine squared theta. And we see that this is equal to 1. Okay, let's not use this color. We see that this is equal to 1. And we see that this is 1 plus. This is the same as saying cotangent squared of theta, and that is equal to 1 over sine. So we can think of it as 1 over sine squared, and we know that 1 over sine is cosecant, which has a symbol like that. And likewise, we can divide both sides by cosine. So cosine squared plus sine. And we find that this is equal to 1 plus. This right here is the same as tangent squared theta, if we bring the powers together. And here, this is the same as saying secant squared theta. And right here, we just got 2 new identities. So in summary, we learned sine squared theta plus, okay, you know what, let's use a different variable, x, but really it's the same thing, equals 1, and we also know that 1 plus tangent squared x equals secant of x, secant squared x, and we also know that this is cosecant squared x, and we are done.